Hello everyone, I am Sukesh. Today I am going to walk you through a full data science project where we analyze the road accident data and even find the hidden patterns using the a priori algorithm. For doing that, first we need to download the dataset from the Kaggle. So let's download it. So this is our dataset. Here we can see the download option, but I have downloaded it early, so I no need to download it again. I'm downloading the zip file. See here it is downloading. I have downloaded it 3 hours ago. So you can go to the next part. After downloading, this contains the more than 23 million records. So we have to trim the data set into the 1 lakh records. So for that, we are using the Python library called pandas. Here, the file we downloaded it is here in this path, and we are reading it to the data frame using the pandas.read CSV, and this data frame holds the file. Now we have to trim the dataset that we have given the variable name as trimwood.df with samples of 1 lakhs, and we after trimming the dataset we have to convert that into the two comma separated file, and we will save that as us actions trimmed 100k.csv. After that we will play if it successfully converts it into 100k dataset, we will print the randomly trimmed dataset is saved as us actions trimmed 100k dataset. So let's see if it is downloaded or not. Yeah, see here it is downloaded. It's opening. Here we can see there are multiple columns like ID, source, severity, start time, end time, like that country, time zone, temperature, weather conditions, everything. This is the data set of 100k values after trimming. This data set contains the null values and missing values. So first we have to pre-process the data. For that, first, we will import the following libraries. Pandas. Pandas is used for writing the tables and cleaning and transforming data. Seaborn is used for visualization of data. And Scicop2. Scicop2 is helps us to connect the PostgreSQL database. And SQL Alchemy let's connect to cleaner way using connection strings, and base map is used to draw maps like maps in Python. And to implement a priori and association rules we have to import the ml extend library, and we have to import the frequent patterns from them. And after that we have to connect the database into the PostgreSQL. Let's see how we can connect that. I am opening the PostgreSQL app here. Now here the option servers is there, we have to click that. First it will ask us to enter the password which we set during the any installation time. Now in the schemas in public, we have to go to the tables. We have to go to query tool. Here first we have to create the table with what are the columns we are needed. I have already created that. Now I am just showing it. This is the table structure of table I have created. So let's see what it contains. We are creating the table named US accidents new and with ID as the primary key, and these are all the columns we are considering, and we have also considered the type of columns. After creating the table, we have to copy the data. See this query. We have the US accents trimmed, which we downloaded in the beginning, which has the 100K values. We have to copy that into the US accents new into the PostgreSQL. We have to use the delimiter as comma because it is a comma separated file CSV, and we have to use the CSV header. After that, if you want to check if the table is created or not, we can run this command. Let's see what happens. Yeah, here we can see that the table is created in PostgreSQL with the columns like ID, source, severity, start time, end time, like everything. We have created the like 42 or 43 columns. All columns are replicated here. Now we can go back to the Jupyter nodes. From the PostgreSQL, we have to import the table into the Jupyter notebook. For that, we will be creating an engine which takes this. Here, we have to use the password which we set during the installation time, and we have got the data. Now, we from that data, we have to read the SQL into the data frame using the pandas library. If you want to check whether the data is loaded into the data frame or not, we can print the df.head, which gives the first five values, initial five values. We can check here, first five values are listed. These are all the columns. Now, like I said earlier, we have to do the pre-processing. Here, df is equal df.log. If at any column which has the less than zero point 0.5, half of more than half of null values, we have to drop that columns. Like we cannot fill the more than half of the values in pre-processing. We can simply delete that column. If any row is having a null value, we can simply drop that row. In 43 columns, if the, any one has null value, we can delete that entire column. Now, after clearing the all the rows and columns, we are having the df.info, which gives the data, which is the column and the column type and the number of objects and the data type, like ID, which is not null, and its type is object. Like we have many columns like source, severity, start, end time, city, country, code. Everything will be not null, and everything will have a certain data type associated with it. Bool, which gives you only two values, true and false. Now we are handling the missing values for column in df.columns. If it has the type object, we can fill the values with the mode. Like if what in the column, if we can calculate the which value has the higher frequency, we can fill the missing values with that column with that mode. Mode means which is repeating high. Else we can fill them in another way, like we can fill them with median. Now after completing the pre-processing, we have to we are again checking the whether the missing values are pre-processed or not. We can write df.head, which gives the following values. This Seaborn library we have discussed earlier is used to visualize the data in bar graphs form. As we can see here, is severity. We are plotting the severity with respect to the count of the accidents. 40,000 accidents will have the severity 2, and very less accidents have the severity 1, 3, and 4. From that, we can say that the severity 2 has the highest number of accidents. Now, after that, we are plotting according to the weather conditions. See, we are listed all the weather conditions. The accidents occur mainly during the fair weather conditions, which occur due to the imbalance in the dataset. Like here we see cloudy has more accidents and mostly cloudy. You can see for every weather type we are having the number of accidents occurred. See the count 0, 5,000, 10,000. We can visualize how many accidents compared to the other weather conditions. Now we can select the states. In US there may be more than 50 states, but we are giving the top 10 states which has the highest number of accidents. Like dot head, in head if you pass the parameter as 10, it will give the first 10 values in the descending order. See the California, Florida, Texas, New York, Massachusetts. These states have the highest number of accidents, with California recording the most number of accidents, 12,000, and Florida with approximately 7,000. Now we know that USA is a very big country. In USA, it's a very big country. We can have the different time zones like Eastern time zone, Pacific time zone, and Central time zone, and Mountain time zone. We can divide the data into the which region had the highest number of accidents, like that also. Eastern region has the highest number of accidents, and later Pacific, which records around 14,000 accidents, and US Central has around 7,000, and the least number of accidents occurred in US Mountain time. Now here see we are plotting the US map with the 50 states with four time zones as US Eastern, US Central, US Mountain, and US Pacific. We are setting the high risk accident zones as orange color and green color. Here we can see the spread is not evenly spread. It was accumulated at particular places. Like here we can see, and here also we can see that. Here in the before we have seen that the accidents reflect the time zones and states and etc. Now within the streets also, which street had the most number of accidents? We have several most number of streets in USA. Among that, we are filtering the top 20 streets which have the highest number of accidents, and using the Seaborn library, we are plotting them. See, the here it listed the top 20 streets with most accidents, like 95 north, 95 south, 5 north, south, east. Like directions also it gave you. As it is streets, it has lesser number of accidents when compared to the whole city or whole country. So that your number of accidents scales up to 100, 100, and 500 might be the most number of accidents. And again, we are importing Matplotlib, which is used to plot the data like pie charts, bar graphs, as PLD, and Seaborn, which is used to visualize the data drawn by the Matplotlib. Here we can see we have drawn the percentage of accidents according to the weather conditions like cloudy, fair, fog, light rain, light snow, cloudy, party rain. Here, percentage of accidents by time of day and weather conditions. Like, look, in cloudy daytime, we have more number of accidents in compared to cloudy night, which slightly lesser number of accidents. Like, if you are having fair, we will see the whether the accidents has occurred at the daytime or night time. Like in fog, it has occurred lesser in day or night. We can compare between the day and night time also. If we are given the weather condition, we can compare and contrast between the day and night. Like simply we do not give the which weather condition has the highest number of accidents. In that weather condition also, we are giving the segregating the day and night accidents. Now here we are seeing the heat map of accident percentages of by time of day and weather conditions. Like in cloudy, we 8.83 percentage of accidents occur at the daytime and 6.83 occur at night time. Like in fair daytime, look particularly we are giving it in red color, means most number of accidents like are likely to be occurred at the daytime in fair condition. In light and fog condition, we are having relatively lesser number of accidents. Like we can check for the other condition also: light rain, light snow, cloudy, partly cloudy, and rain. Now it is the prediction condition. Like if user enters the environmental conditions in which he is surviving, like temperature, he can enter in Fahrenheit, and humidity percentage, like he can enter like the approximate value, like he may not enter the correct value, visibility and the wind speed and precipitation. We can, here we are having the three models: random forest model, logistic regression model, and deep learning model. Here we can see the discrepancies in the percentage. We can consider random forest and deep learning. They gave the correct percentage of correct like a similar percentage of actions, while logistic regression hasn't considered the every feature. It simply considers one or two features and gives the percentage, so that it gives the different value compared to random forest and deep learning. Here we are training the data in random forest model, logistic regression model, and deep learning model. We are using three models: random forest, logistic regression, and deep learning. Continuing with epochs, and after training the models, we are predicting the weather conditions and road conditions according to the user input. Here, user can enter the current road and visibility conditions, and he can input whether it is a day or night, and input the weather condition like clear, fog, rain. He can input approximately, and after training the model here, we are predicting the model according to the user input. Like we can use random forest model and deep learning model. We can ignore the logistic regression model as it is providing the outliers. And that's it. We pulled accident data from PostgreSQL, cleaned it, and pre-processed and visualized, and we ran the a priori algorithm for mining, and finally plotted the map showing the accident locations. And it gives you the solid hands-on experience with databases and mapping all in one. Mm, thank you.